Let me tell you about quarks and leptons. I'm a NAF, and this is my project. No matter where you look around you, every single thing that you see is made up of something called matter. So, imagine I took this about average sized pencil and I broke it into half. I would have half a pencil, obviously, but what if I kept going and I kept breaking this pencil into a bunch of little pieces over and over for a pretty long time? Eventually, I'd have to end up with just the tiniest little bits of pencil. And from what you know from physics and science grades in the past, eventually you'd have to get to really tiny particles like protons and neutrons. But what if we broke those protons and neutrons down themselves? Could something so small like protons and neutrons be made of something else? The answer is quarks. Quarks are the fundamental particles that make up protons and neutrons. They were discovered in 1964 by these two scientists named Murray Gell-Mann and George Zweig. Very German. They're found in the nucleus of protons and neutrons, and there's 6 different flavors to them. And I found this ridiculous. They're actually called flavors, the different types of quarks. It's not like you can eat them, I guess, but they call them flavors. The flavors are up, down, strange, charm, top, and bottom. There's 6 of them. The naming convention is a bit weird, I'll be honest, but they help physicists differentiate between the types of quarks. Up and down quarks are the most plentiful in our world, as most matter consists mostly of up and down quarks. Quarks are never found alone. They actually have to combine with each other and another type of particle called a gluon to make something called a hadron. A hadron is when quarks and gluons come together to make things like protons and neutrons that I'm sure you're familiar with at this point. Protons consist of 2 of the up flavor quarks, which have a 2/3 charge each, and 1 of the down quarks that has a negative 1/3 charge each. Neutrons are the opposite with 1 up quark and 2 down quarks. Speaking of charges, quarks do have them. Usually in physics, we see charges as whole numbers, but it's interesting to see that quarks have fractional charges of either a positive 2/3 or a negative 1/3. And next up is leptons. Leptons are the second group of fundamental particles. And at this point, you've heard a lot of talk about protons and neutrons. But you're probably wondering, where's the other brother in this situation? The electron. Funny you mention that, because the electron is a type of lepton, probably the most famous of all of them. And another famous lepton would be the neutrino. Neutrinos are incredibly small particles that rarely react with matter. And fun fact, right now through your hand, there are trillions of neutrinos passing through you. So, if you wanted to feel like a superhero, you could totally feel like Neutrino Man right now and shoot a bunch of neutrinos. Although that is a lame power, because you're not really doing anything. I should probably cut that out of the video. That's the lamest thing. So, similarly to quarks, leptons actually come in the 6 weird flavors. But, unlike quarks, leptons actually exist by themselves. They don't have to come together with gluons to make a hadron like quarks do. Now, while it's true that leptons come in 6 flavors just like quarks do, they're not named the same way. The 6 leptons are as follows: electrons, tau, muons, electron neutrino, tau neutrino, and muon neutrino. It's worth mentioning that unlike quarks, these come in whole charges and not fractional. The science application. Scientists discovered quarks and leptons using these really big machines called particle accelerators. That is a particle accelerator. Specifically, the famous LHC particle accelerator. These machines are incredibly powerful, and they have particles smashed together at incredibly high speeds to observe what happens during those collisions. And from those collisions, we found quarks. Even nowadays, scientists and physicists still don't actually know everything about quarks and leptons. Matter of fact, we're not even sure that they're the smallest fundamental particles yet, which is kind of crazy. Maybe quarks and leptons are made of even smaller particles? It might be possible. We don't know yet, though. Quarks and leptons are not visible to us, but they're what every single thing is made out of. And a little question for you to think about: Compare and contrast the differences and similarities between quarks and leptons. Alright, one last question before we wrap up. Briefly detail the particle accelerator experiment that discovered the existence of quarks.